Hello students, welcome to the channel. In this video, we'll solve the fifth and final reading passage of the March 2020 US SAT. This is the paired science passage. Passage 1 is adapted from Christina Eisenberg, The Carnivore Way, Coexisting with and Conserving North America's Predators. Passage 2 is adapted from John R. Squires and others, Missing Links and Trophic Cascades in Food Webs, a reply to Ripple and others. A trophic cascade occurs when the presence of a predator decreases the population of its prey, thereby increasing the numbers of organisms at the next lower trophic level. So this passage is going to be about trophic cascades. So for example, let's say that this is an apex predator and this is the prey for the apex predator and this is the prey for this one. So let's call it this prey 1 and this prey 2. So what is the meaning of a trophic cascade? That if the presence of the apex predator leads to a decline in the number of prey 1 on which the apex predator feeds, then that leads to an increase in the numbers of prey 2 on which prey 1 feeds, right? So that is what a trophic cascade means, that the presence of a predator at one trophic level can affect the numbers at subsequent trophic levels. Passage 1. In the early 2000s, wolves began to drift down from Canada and across the border from Idaho into Washington state. This natural wolf recolonization inspired ecologists such as William Ripple and his colleagues to conduct an exercise in scientific thinking to consider potential impacts that an apex predator like the wolf would have on the intricate workings of the lynx snowshoe hare food web. At the time, Washington had low hare and lynx populations and a high coyote population. Coyotes had recently expanded their range and abundance there. Wolves prey on coyotes. What if the wolves return to the Pacific Northwest could indirectly improve lynx conservation via trophic cascade levels? So this introduces the apex predator as the wolf, which feeds on the coyote, and the coyote feeds on the lynx, right? So because of the low lynx numbers and the presence of coyote, scientists were interested in how the natural migration of wolves from Canada and across the border into Washington state might lead to a decline in coyotes population, which in turn could lead to an increase in the lynx population. Ripple and colleagues hypothesized that two mechanisms would drive wolf, coyote, lynx, snowshoe hare trophic cascades. First, by killing coyotes, wolves would reverse the mesopredator release that had occurred when wolves had been extirpated from this region nearly a century earlier. When humans hunted wolves to extinction, they removed an important check on coyote numbers, creating a release on the numbers of this mid-sized predator. Okay, so the first line of inquiry was about the extinction of wolves that had taken place due to human activity, the extirpation, the extinction of wolves that had taken place, and how that had led to a release on the number of the mid-sized predator, the coyote, which in turn had led to a decrease in the numbers of lynx. Coyote numbers increased, which put more pressure on lynx via competition for food resources such as snowshoe hares. Thereby, by reducing coyotes in this system, a returning wolf population could indirectly create ecological benefits for lynx. The researchers further hypothesized that because coyotes also prey on lynx, a reduction of coyote numbers by wolves would release predation pressure on lynx. Okay, so there was one, obviously, was the fact that decrease in coyote numbers would release predation pressure on lynx. But then the other part was that lynx was also at the same level in terms of their common prey, right? They both preyed on snowshoe hares, right? So if the coyote numbers declined, then snowshoe hares would be available for predation by lynx, right? So on two counts, there could be a benefit to the lynx population. Second, in Western North America, south of the US-Canada border, wolves prey primarily on elk and deer. When elk and deer numbers are high, these herbivores can suppress shrubs via heavy browsing. Ripple and colleagues hypothesized that the wolves' return would reduce elk and deer numbers and also change their behavior, as has been found in places like Yellowstone by John Laundrie and others. Elk and deer need to stay alert in order to survive in areas where wolves exist. This means keeping their heads up and spending less time standing in one spot with their heads down, as they typically do when there are no wolves in a system. Via this predation risk mechanism, wolves could indirectly reduce browsing pressure on shrubs, which would improve snowshoe hare habitat, thereby benefiting lynx. Okay, so the other mechanism by which the wolf population could help lynx was by the wolves' predation of elk and deer. When wolves are not present in an environment, then elk and deer spend considerable time browsing, that is, grazing on shrubs. But when wolves are present, then they spend less time browsing. And so the shrubs can grow, and those shrubs are in turn eaten by the snowshoe hares. And so they can improve the snowshoe hare habitat, which in turn would benefit the lynx. So there are these two mechanisms, the coyote mechanism and the elk and deer mechanism, both of which could have an indirect benefit for the lynx. Okay, so let's attempt questions from the first passage. One important function of the first paragraph of passage 1 is to. So what was happening in the first paragraph? This natural migration of wolves that had occurred, this natural wolf recolonization, inspired ecologists such as William Ripple and his colleagues to study the potential impact that this would have on populations of the animals further down the trophic chain. So one important function is to assert the strength of the assumption that informed the hypothesis that Ripple and his colleagues developed, describe the ecological situation that Ripple and his colleagues considered, define important concepts that Ripple and his colleagues employed in their research, compare behavioral traits of the animals that Ripple and his colleagues studied. So let's work with elimination. I don't think it's D because behavioral traits of the animals were not compared. What was done was that the natural colonization that was taking place by wolves, that was studied. Also, important concepts were not defined, so it's not C. B is a good answer. It does describe the ecological situation, the recolonization by wolves that Ripple studied, so I like B. Assert the strength of the assumptions that inform the hypothesis. I don't think the assumptions that inform the hypothesis are brought up in detail there, right? This is more to do with the questions raised by this situation, right? The assumptions come later, right? So these are the assumptions that the first case of the coyote pathway and the other of the elk and deer. Yeah, so assumptions are not in the first paragraph. So I think the best answer is B. As used in line 16, drive most nearly means. So Ripple and colleagues hypothesized that two mechanisms would drive wolf, coyote, lynx, snowshoe hare trophic cascades. Two mechanisms would cause, right? To drive is to cause those trophic cascades. So I like A. You can't convey a cascade, right? This is basically a sort of natural progression along a food chain. So it can't be conveyed. You can't operate a cascade. This is something that happens naturally. And you can't repulse it. To repulse is to have a feeling of disgust. So that doesn't make sense in context. Passage 1 indicates that Ripple and his colleagues would expect to find that in areas where wolves have returned, elk and deer feed on fewer varieties of shrubs than do elk and deer in areas where no wolves are found, exist in lower numbers than they did prior to the local extermination of wolves, graze for shorter periods without interruption than they did before the return of wolves, and demonstrate less fearful behavior towards coyote than towards wolves. So I think it's C, right? Because in areas where wolves have returned, they graze for shorter periods without interruption. This is given here. This means keeping their heads up and spending less time standing in one spot with their heads down, as they typically do when there are no wolves, right? So this means that their time spent browsing would be reduced, right? So C is a good answer. Is this evidence-based? No, passage 2. Okay. What about option A, feed on fewer varieties of shrubs? So there's no mention of varieties of shrubs, so it's not A. Exist in lower numbers than they did prior to the local extermination of wolves. So this is local extermination of wolves is only specific to this was specific to this region, and this was in regard to the coyotes, not in regard to elk and deer, so it's not B. And demonstrate less fearful behavior. So there is no mention of coyotes' response or coyotes' impact on how elk behave, so it's not D. Okay, so we now need to read passage 2. Ripple and others correctly state that wolves can affect coyotes both behaviorally and ecologically in the greater Yellowstone ecosystem, as shown by Berger and Geese, and that such regulation can have cascading effects. However, despite the well-publicized initial declines in coyote abundance in the GYE following wolf recovery, coyotes may now be adapting to wolves, and coyote pack numbers may have rebounded. The trophic strength of wolf effects on coyotes may also differ geographically with variation in climate, primary productivity, carnivore and prey communities, and the degree of human persecution. The inverse relationship between wolves and coyotes in Yellowstone is not supported outside the two national parks, Yellowstone and Grand Teton, included in the analysis by Berger and Geese. In other systems where wolves, coyotes, and lynx coexist, research shows a positive relationship between wolves and coyotes, whereby coyotes benefit from scavenging on wolf-killed ungulate carcasses. Okay, so this passage kind of challenges the hypothesis that Ripple forwarded by saying that, yes, Yellowstone does show a sort of negative relationship between wolf and coyote numbers, but that relationship is not borne out in other parts of the country. And that relationship is informed by a variety of factors like climate, primary productivity, carnivore and prey communities, and the degree of human activity, right? So this passage takes a more guarded view of how the apex predator wolf affects the coyotes. In fact, it goes on to say that wolves can have a positive effect on coyotes because they provide uh, coyotes with nourishment in the form of the carcasses that they feed on. Coyotes then scavenge those carcasses. The generally low mortality rates of radio-collared coyotes killed by wolves outside of Yellowstone in northwest Montana is 3 times less than those killed by cougars. Thus, this quick review of the literature suggests that the strongest generality of Ripple's hypothesis that wolves have a direct negative effect on coyotes is at best inconsistent, both within the GYE and across wolf-coyote range in North America. Okay, so this says that coyotes may actually be facing a greater threat from cougars than from wolves, and so Ripple's hypothesis does not really stand. Buskirk and others hypothesize that coyotes compete with lynx through both interference competition, direct killing or displacement, and indirect exploitative competition for shared food resource. Okay, so this talks about what Ripple also said, that there is both interference competition, direct killing or displacement between coyotes and lynx, and there is also indirect competition for food resources. Ripple and others speculated that these interactions are in part responsible for the imperiled state of southern lynx. Unfortunately, evidence for interference competition is essentially limited to anecdotal observations. An observation of a single juvenile lynx killed by a coyote in the Yukon is not prima facie evidence for a trophic level interaction. Further, in this northern population, more predation mortality of radio-collared lynx was attributed to wolves, wolverines, and other lynx than to coyotes. Direct interactions between coyotes and lynx were rare. Okay, so here again, the hypothesis that Ripple forwarded about the competition between lynx and coyotes, both in terms of interference and for shared food resources, doesn't really stand in the face of evidence. Evidence for interference competition is anecdotal. This observation of a single case is not sufficient evidence for a trophic level interaction. And here again, we notice that lynx have greater threat from wolves and wolverines than to coyotes, right? So if we were to articulate the relationship between the two passages, we would say that the first passage, Ripple presents a hypothesis about how there is a trophic interaction along the wolf, coyote, lynx, hare level, and that interaction leads to numbers changing based on the presence or absence of a predator. And the second passage cancels that. Second passage questions that assumption and says that no, there are other factors at work. Okay, 46, which choice from passage 2 best supports the idea that findings about the effect of wolves on coyotes in some locations may not be representative of the effect of wolves on coyotes in all locations? 49 to 53, 53 to 57, 49 to 53, 53 to 57, 61, 64, 78, 81, 61 to 64, 78 to 81. Okay. Ripple correctly states that wolves can affect coyotes in the Greater Yellowstone system as shown by Berger and Gies. Right, so in the Greater Yellowstone system, this was true. However, despite the well-publicized initial declines in the coyote populations in the GY, coyotes may now be adapting to wolves. Okay, so they're adapting to wolves, that's fine. The inverse relationship between wolves and coyotes in Yellowstone is not supported outside the two national parks. So this is the evidence for how the inverse relationship observed in Yellowstone is not true in other places. So I like C. Buskirk hypothesized that coyotes compete with lynx through both interference competition and indirect. Okay, so this moves to coyotes and lynx. So this does not have to do with wolves. So C is the best answer. The authors of passage 2 provide information about coyote mortality rates in Northwest Montana, most likely to. So that is here. The generally low mortality of radio-collared coyotes killed by wolves outside of Yellowstone is 3 times less than those killed by cougars. So what is the purpose of this? To offer an alternative explanation for coyote declines in the Greater Yellowstone system, emphasize the strength of the wolf-caused trophic cascade in that area, illustrate the claim that the presence of wolves can indirectly benefit coyotes, support the claim that wolves may not always pose a major direct threat to coyotes. So I think it's D. D is a good answer because the author is trying to say here that that wolves and coyotes can actually have a positive relationship whereby coyotes benefit from scavenging, right? And then that is supported by the generally low mortality rates of radio-collared coyotes, which are 3 times less than those killed by cougars. So the idea that wolves may not always pose a direct threat is supported by the numbers in Montana. So I like D. This is not to support the idea that wolves can benefit coyotes. That is not an illustration of that claim. That illustration has already come from the scavenging bit, so it's not C. This is not showing the strength of wolf-caused trophic cascade. In fact, it is saying that the wolf-caused trophic cascade is not as strong as Ripple says, so it's not B. And I don't think it's offering an alternative explanation, right? It's not an alternative explanation. It is saying that, yes, there is a threat to coyote population from wolves, but it is not as major as is perceived, right? So yes, so D is better worded. In line 81, the authors of passage 2 use the word shared most likely to indicate that coyotes and lynx, so they have shared food resources, right? So coyotes and lynx have some overlap in their diets, will sometimes feed together, are both preyed on by wolves, may scavenge each other's prey. So they have some overlap in their diets, right? That's exactly what we mean by shared food resources. That in fact, this idea was first introduced in the first passage, that coyote numbers increase, which put more pressure on lynx via competition for food resources. So snowshoe hare is an example of a food resource that is common to both coyotes and lynx, right? So that's what option A says. It's not about feeding together, so that's not B. And if they are both preyed on by wolves, then that's not a shared food resource, so it's not C. And there's no mention on their scavenging on each other's prey. Okay, which choice best describes the relationship between the passages? Passage 2 presents information that challenges aspects of the hypothesis described in passage 1. Passage 2 casts doubt on the authenticity of the data supporting the hypothesis offered in passage 1. Passage 2 argues for the need for modifications to the hypothesis advanced in passage 1. Passage 2 discusses a study intended to test parts of the hypothesis presented in passage 1. So it's A, right? Because the information that the second passage presents, information related to the effect of cougars, the juvenile lynx that was killed by a coyote, all of this information raises questions about the hypothesis that Ripple presented. So that's a good answer. It doesn't cast doubt on the authenticity of the data. The second passage is not saying that Ripple's data is inaccurate, so it's not B. It doesn't argue for modifying that hypothesis. At no point does it say that the hypothesis needs to be modified. It's rather saying that the hypothesis may not be correct entirely. And it doesn't discuss a study, right? It only presents these snippets of information that challenge aspects of the hypothesis. So, right, so it's not D. Based on the passages, Ripple and his colleagues and the authors of passage 2 would likely agree with which statement about wolves and coyotes. Wolves and coyotes typically occupy the same trophic level in an ecosystem. It is possible for wolves to initiate trophic cascades through their effect on coyotes. There are some circumstances in which the presence of wolves may benefit coyotes. Wolves and coyotes can have both ecological and behavioral effects on large herbivores. So I think it will be B, right? Because even the second guy is saying that it is possible for wolves to initiate trophic cascades, right? Wolves can affect coyotes, both behaviorally and ecologically, right? So the main theme of Ripple's passage is supported in the beginning of the second passage, that can happen. So it is possible, right? So B is something they both agree with. Wolves and coyotes typically occupy the same trophic level. Neither author is saying that, so it's not A. There are some circumstances in which presence of wolves may benefit coyotes. This is only true for the second passage, not the first one, so it's not C. And wolves and coyotes can have both ecological and behavioral effects on large herbivores. No, so I think the passage is talking about behavioral and ecological effects on one another, not on other animals, so it's not D. The authors of passage 2 suggest that the hypothesis described in lines 28 to 32 is, okay, so what is 28 to 32 saying? 28 to 32, this one. The researchers further hypothesized that because coyotes also prey on lynx, a reduction of coyote numbers by wolves would release predation pressure on lynx. Okay, so coyotes prey on lynx. Okay, that is what Ripple was saying. So contradicted by anecdotal observations, valid for many populations, but not for all, difficult to test in a natural setting based on insufficient data. So I think I can definitely eliminate B and C, because the second author is definitely saying that what we have seen with the juvenile lynx being killed by a coyote is not evidence for a trophic level interaction, right? So it's not something which is true. And I don't think contradiction is a good word. That's a very strong word. It's contradiction would mean that the opposite is happening, right? So I don't think that is a good answer. You could say that it is challenged by, right? I would have liked the word challenged because anecdotal observations don't support it, right? So I think D is better worded, that this is based on insufficient data and prima facie it is challenged. So I like D, but I'll just look at the evidence and then confirm. 65, 68, 69, 72. 65 to, okay, so let me just change the color for this. Okay, 65 to 68. What was the next one? 69, 72. 69 to 72. Okay. Then 82, 84, 86, 88. 82 to 84 and 86 to 88. Okay. So the first two options relate to wolves and coyotes, so they are not relevant to coyotes and lynx. Ripple speculated that these interactions are responsible for the imperiled status. Okay, so that's what Ripple said, but an observation of a single juvenile lynx killed by a coyote is not prima facie evidence for a trophic level interaction. Yeah, so it's D, because in D we are talking about a trophic level interaction, and so it is based on insufficient data that one observation is not good enough. So D for 51 as well. Okay, let's grade this 43 onwards. B, A, C, C, D, B, A, C, C, D, A, B, double D, A, B, double D. Okay, great. So we got all correct. With this, we complete the solutions for the reading section of the March 2020 SAT. And we have already completed solutions to the writing and the math sections before. So now this paper has been solved in its entirety. I'll link to the solutions in the description box, so do check those out. If this helped, hit like and subscribe to the channel. I'll see you guys soon. Take care. Bye-bye.